In second part of DC analysis of first stage of IC741 operation amplifier, we can see transistor number Q8 and Q9. Transistor number Q8, this is basic current wave. Q8 and Q9 are the basic current mirror, and Q8 is connected to Q1. This is plus input terminal, and it is connected to Q2 negative input terminal. This is transistor Q3. Q1 is NPN transistor and Q3 is PNP transistor. This is Q4. And it is connected to IC10. And IC10 I have calculated is equal to 19 microampere. So here Q1 and Q2 are the input transistors of the operation amplifier, and IN positive and IN negative are the AC signals. That's why I am doing DC analysis. That's why these should be ground, because I am doing DC analysis. So AC source should be grounded. Now, because both transistors should be matched, so if the current is I in the Q1, so current in Q2 should be I. Okay, and here current should be 2I. Okay, so we know in basic current mirror, if the current source current is 2I, then in load it will be equal to 2I into beta upon beta plus 2. So here source transistor is Q8. So here current is 2I into beta upon beta plus 2. And beta should be P, because these are the PNP transistors. Okay, here current is I. So this is the PNP transistor. So this is the ammeter, and it should be equal to I upon beta P is equal to I upon beta P. Similarly, here current will be 2I upon beta P. So we should know the difference between PNP and NPN symbols. So here emitter current is I, so collector current is also I, because base current is negligible, I upon beta P. Here this will be equal to I. Okay, so KCL at node X, KCL at node X gives IC10 is equal to 2I into beta upon beta plus 2, okay, plus 2I upon beta P. As beta is very high, beta P is much greater than 1. So IC10 approximately equal to 2I. Okay, and we have calculated IC10 19 microampere equal to 2I. So the value of I is 9.5 microampere. 9.5 microampere. Now Q5, Q3 and Q4 are connected to Q5. Okay, this is Q7, Q6 is connected to Q16. This is not the part of stage 1. So we can write 2 16. It is connected to resistance. It is connected to resistance. It is connected to resistance. Minus 15, minus 15, minus 15. R1 is equal to 1 kilo ohm. R3 is equal to 50 kilo ohm. And R2 is equal to 1 kilo ohm. So, how to calculate the value of I7? How to calculate the value of I7? Because I am neglecting the base current here. Okay. So I7 can be calculated as KCL. This is current, base current of Q6. This is base current of Q5. So here current is I. Here current is I. So here current will be I upon beta n. So this is NPN transistor. I upon beta n. And here current, if this is the voltage Vx, so Vx upon R3. And this is the current I dash. So this is the value of I dash plus I upon beta n plus I upon beta n. So how to calculate the value of Vx? Vx is nothing but the potential difference. Vx is nothing but the potential difference. So we can write plus minus Vx, and this is A and this is B. Okay. So we can see this is VBE 6. This is resistance R2 1 kilo ohm, and current is I6 minus, it is minus minus plus minus plus 15 volt. Both are grounded. So V6 is nothing but the potential from A to B. So we have to move from A to B. So VAB is equal to VBE 6 plus R2 into I6 minus 15 plus 15. So this is the value of Vx. I6. Here VB6 is I So with the value of IC6 is equal to I, so we can find the value of VB6 using the formula VT ln IC6 upon IS. Okay, so we can find the value of VB6. What is the value of VB6? 20 VT is 26 millivolt ln IC6 is I 9.5 into 10 to the power minus 6 upon IS 10 to the minus 14. So VB6 is equal to approximately 517 millivolt. Okay, and IC7 or I7, IC7, or you can say I7 is equal to 10.5 microampere, and this comes from the equation number 1. Get the value of IC6 or IC7. IC7, sorry, IC7.